A fundamental theory. A theory that explains all biological phenomena is inherently greater than one that addresses only human intelligence and consciousness. Are human intelligence and consciousness not biological phenomena? Are they not outcomes of biological evolution? Are neurons and the human brain not products of this evolutionary process? Are human beings not biological entities, the outcome of the evolutionary process? Is science and philosophy not conducted by human beings? Is language not a tool used by human beings? Are machine learning systems, neural networks, and scientific theories not created and implemented by human beings? Again, are human beings and human activities not part of the biological phenomenon? Do all these phenomena not exist within the same universe? If we examine all these phenomena objectively, we must acknowledge that they are undeniably biological in nature. If this is the case, then a theory that explains all biological phenomena is unquestionably greater than a theory that explains only human intelligence and consciousness. The Patternist approach to finding a theory that can explain all biological phenomena follows the same process as all other great scientific theories. First, collect and observe as many related phenomena as possible. Then, organize and categorize the phenomena so that patterns become more apparent. Finally, identify and extract patterns and regularities to use as principles for a theory. For a theory that explains all motion in the universe, all instances of motion are observed and collected: the movement of the moon, the planets around the sun, and vehicles on Earth. The study of pendulums, the interaction of gravity on objects in controlled experiments, the ballistics of cannonballs and rockets, the perihelion of Mercury, time dilation observed in GPS satellites, and the bending of light during a solar eclipse. A comprehensive theory of motion must account for all these phenomena. For a theory of electromagnetics, the same approach applies. All instances of electromagnetic interactions must be gathered and analyzed. Natural phenomena like lightning and Earth's magnetic poles, technological devices like batteries and capacitors, biological systems such as the sodium-potassium pump and electric eels, the various methods of electricity generation, whether by wind, water, or nuclear turbines, the generation of torque for movement using an electric engine, different types of arc welding, electromagnets, rare earth magnets, and superconductors. All of these phenomena must be included within a theory of electromagnetics. For a theory that explains quantum phenomena, various experiments in physics must be considered: the study of pressure, volume, and temperature of gases, spectrum analysis, particle accelerators, bubble chambers, the double-slit experiment, and X-ray crystallography. All these experiments and their findings must be gathered and accounted for in a comprehensive theory of quantum phenomena. For a theory that explains all biological phenomena, all instances of biological organisms and their activities and interactions are collected. The various forms of sensory organs, the act of reproduction, eating and repairing, meiosis, mitosis, and all phenomena related to viruses. Since human beings are biological, all human activities, including human intelligence, consciousness, science, manufacturing, language, are part of the biological phenomena and must therefore be accounted for in a complete theory. The Patternist approach to explaining all biological phenomena follows the same methodology as all other great scientific theories. Decompose all related phenomena into an interacting set of principles. Newton broke down all motion-related phenomena with his 3 laws of motion, resulting in Newtonian mechanics. Electromagnetic phenomena were unified through Maxwell's equations. Quantum phenomena are explained by quantum mechanics and Schrödinger's equation. Darwin's theory of natural selection explained biological phenomena through the principles of reproduction and differential survival. It is the phenomena that are important. Theories are merely representations, attempts to break down phenomena into principles to enable accurate predictions, simulations, and engineering feats. If a theory cannot explain all related phenomena in its field, it cannot be considered complete. When new phenomena are observed through advancements in technology and sensors, and the prevailing theory cannot account for them, that theory must be treated as outdated. It must either be corrected or replaced by a more fundamental theory. All great theories have been refined in this manner. Einstein's theory of relativity corrected Newtonian mechanics by adding the principle of the constant speed of light, addressing the failure of Newtonian mechanics to account for various astronomical observations and experiments involving the speed of light. Maxwell's equations, which worked well for large field lengths and high field strengths, were improved to account for small distances and low field strengths, resulting in quantum electrodynamics. For quantum phenomena, there were several models of the atom before the development of quantum mechanics and Schrödinger's equation, not to mention the mathematical advancements required to solve these equations. The modern theory of evolution synthesizes Darwinian natural selection with population genetics, incorporating insights from genetic sequencing and our understanding of DNA. But the modern theory of evolution remains incomplete. Its scope is far too limited to account for all biological phenomena. It cannot fully explain or generalize how sensors function, the mechanisms of camouflage, the nature of communication and language, or essential processes, like reproduction and eating. As it stands, the modern theory of evolution fails to explain the full range of well-documented biological phenomena. Patternism is an update to the modern theory of evolution. It builds on and refines both the traditional theory of evolution and its contemporary framework. Patternism seeks to account for all biological phenomena, expanding the scope to include all human phenomena while providing a more detailed explanation of existing biological phenomena through the mechanisms they employ. The methodology used in Patternism is the same as in all great scientific theories. Take all related phenomena and break them down into a set of interacting principles. Ironically, in its effort to explain all biological phenomena, Patternism inadvertently identifies a viable set of principles that also account for human intelligence and consciousness, forming a complete theory of intelligence that applies to any system capable of learning and adapting. Representation, recognition, reproduction, and randomization form a viable set of principles for a complete theory of intelligence. For any biological phenomenon, whether in humans, diatoms, or viruses, including the very existence of the organism itself, these phenomena can be broken down into different aspects of representation, recognition, reproduction, and randomization. Each principle in this viable set is worthy of pursuit as a standalone theory. A general theory of representation that explains all forms of representation would be immensely valuable. Such a theory could account for diverse phenomena, including mathematics, scientific modeling, measurement, language, genetics, encryption, simulations, currency, and even systems of government. Understanding how representations are created and utilized, their limitations, and methods to maintain their accuracy and prevent corruption would enable the construction and engineering of new representation systems, preserve their integrity, and support the repair of existing ones, regardless of the form the representation takes. The same applies to recognition. A general theory of recognition that accounts for all forms of sensors, both mechanical and biological, from eyes, ears, and touch to whiskers and antennae, to radar, thermal vision, keys and locks, and even detectors and particle accelerators, would be incredibly valuable. Understanding how sensors are constructed, their limitations, and their operation would lead to the creation of new sensors, improvements to existing ones, and solutions to current issues. Recognition goes beyond sensory perception. It also encompasses labeling, naming, categorization, identification, description, and differentiation. What is language, and how does it function? How does a scientific field guide identify organisms? How does an organism recognize prey, predators, or members of its own species? And how does it know what action to take in each case? What is color in practical applications? Understanding these aspects of recognition would lead to the development of new categorization systems, innovative recognition methods, and advanced sorting techniques. It would also help solve issues related to miscategorization and deception, where sensors and recognition systems are exploited by hostile agents. A general theory of reproduction that covers all forms of reproduction, from biological reproduction in living organisms and industrial production to the teaching of techniques in a classroom, as well as technological and ideological reproduction, is valuable in itself. A practical focus on the ship of Theseus problem, incorporating phenomena such as eating, copying, and repairing, will also address many critical aspects of reproduction. A fully general theory of reproduction would enable more efficient reproduction methods, hacking of reproduction systems to produce specific outcomes, such as in genetic modification, and the prevention of unauthorized reproduction. The phenomenon of reproduction also connects to evolution and the refinement processes of both biological and technological systems. A general theory of randomization that accounts for all instances of its use would be highly valuable. This includes the use of scouts, whether by ants, bees, the military, or nations exploring new territory. It also encompasses sexual reproduction, meiosis, and the shuffling of genes. In what situations is sexual reproduction preferable to cloning? What does it mean to conduct control experiments by varying a single variable at a time and observing the results? Randomization also includes self-referential algorithms designed to maintain unpredictability and disrupt patterns in the presence of a hostile intelligent agent. The universal method was applied to the entire collection of biological phenomena to uncover the principles of representation, recognition, reproduction, and randomization. These principles serve as categories, dividing the entire collection of biological phenomena into smaller subcollections. The universal method is then reapplied to each subcollection to identify internal regularities, breaking each principle into finer components, enabling a deeper understanding of its mechanisms. Using the universal method, the diverse phenomena of representation were broken down into three components: a representative form, a translation machinery, and an original form. Similarly, recognition was divided into feature inputs, feature processing, and action output. Reproduction was analyzed through the concept of component part replacement, with the ship of Theseus serving as a foundational thought experiment for this decomposition. Randomization was analyzed in terms of its sources and its roles in environmental exploration and as a countermeasure against other intelligent agents. These derivations may not be entirely accurate. Dividing the collection of all biological phenomena into the primary principles of the viable set may not be the most efficient approach. However, the attempt itself is valuable. Even if what is presented here does not fully capture every phenomenon in detail, applying the universal method will always yield valuable insights. There is no isolation. Each principle in the viable set does not operate independently. It is the interaction among the four principles that yields all biological phenomena. Representation facilitates reproduction, as seen in the function of blueprints and genes. Representation supports recognition, as in thermal vision technology, where thermal readings are converted into black and white images visible to human eyes or a car's dashboard display. Recognition, in turn, supports representation by playing a key role in translation machinery that converts the representative form into the original form. Randomization enhances reproduction by acting as a natural search mechanism integral to evolution. The synergy of these principles enables greater abilities, technological advancements, and complexity than any single principle could achieve alone. The principles of representation, recognition, reproduction, and randomization are universally applicable. They should be regarded as fundamental tools, employable in any form and through any medium. Any intelligent system in the universe will extensively rely on these general principles, consciously or not. These universal tools can be applied to analyze and dissect any biological phenomena, both known and unknown. They can be used to examine the phenomena of intelligence and consciousness, even if the explanations provided in this book do not fully resolve all complexities. Representation is dissected from consciousness by accounting for self-labeling, self-referencing, and the processes by which calculations and predictions are made through language, various forms of mathematics, and neurons functioning as representative tokens. Recognition is dissected from consciousness by accounting for self-recognition, self-categorization, and internal self-sensors, all of which contribute to distinguishing the self from the environment. Reproduction is dissected from consciousness through the propagation of one and the avoidance of self-damage, framing the self as both a pattern and an evolving pattern. Randomization is dissected from consciousness by addressing efficient searching as well as the ability to not follow patterns. By stripping consciousness of its practical applications, what remains is greatly reduced in complexity, making it easier to analyze and understand. This approach applies universally to all human phenomena and interactions without limits. So far, we have taken all biological phenomena and divided them into aspects of the viable set of principles, but we can go further. We can take these principles and ask, is there something more fundamental underlying these principles? By applying the universal method once more in light of everything we've derived, we discover that representation, recognition, reproduction, and randomization are only secondary principles, merely branches of a single tree. There is a fundamental root. That root is patterns. Patternism is the belief that what lies at the core of all biological and intelligent phenomena are patterns and the paradox of the pattern. We see the role patterns play in representation. Without patterns, accurate representation is impossible. The entity to be represented must exhibit consistency. Otherwise, there would be no reason to expend energy storing it as a representation. The translation machinery must also follow a pattern. It must adhere to a code or a consistent set of rules. Otherwise, the translation process would become corrupted and yield inconsistent results. Representation itself is the act of using one set of patterns to represent another. We see the role patterns play in recognition. Without patterns, no sensors can be built. If the separation of entities is not consistent, any sensor, regardless of form or detection target, would be too noisy to be of practical use. The acts of description, naming, labeling, and identification would all lose their value. Recognition at its core is the detection, comparison, and storage of patterns. We see the role patterns play in reproduction. The very act of reproduction is the propagation of a pattern. For reproduction to occur, the component parts must exist as discernible regularities, a pattern, within the environment to be interchangeable. Otherwise, there would be nothing to build with. Eating and repairing also rely on patterns. The process of eating involves capturing, absorbing, and reconfiguring patterns into a component form that an agent can use to sustain its own pattern and reproduce. Repairing involves maintaining a pattern by restoring its features to their original state. We see the role patterns play in randomization. Randomization serves as a means of searching the environment and surrounding space for patterns, and as a countermeasure against other predatory, pattern-seeking agents. Without patterns, there can be no representation. Without patterns, there is no recognition. Without patterns, there is no reproduction. Without patterns, there is no purpose to randomization. And without patterns, there is no consciousness, a pattern observing itself for patterns, a pattern seeking to transform itself by recognizing itself as a pattern. Consciousness is a self-evolving pattern, directing its evolution from within. Patternism is the belief that patterns, and the paradox of the pattern, lie at the core of all biological and intelligent phenomena. If all these principles, and even consciousness, depend so fundamentally on patterns in one form or another, then there can be only one definition of intelligence capable of encompassing the full utility, the essence of survival and the solutions to maintain existence in a destructive world filled with predators, natural disasters, and the decay of time, as well as account for the human phenomena of measurement, mathematics, metaphors, language, and theory creation. If the word intelligence is to hold the highest significance, then intelligence must be defined as the search for and utilization of patterns. The decomposition of a collection of phenomena into a single set of principles can be understood as breaking down an entity into its fundamental component parts. When we apply this process to all entities in the universe, we will arrive at one of the most successful scientific theories ever proposed: atomic theory, which has accurately accounted for the extensive phenomena related to the constitution of matter. We begin with the collection of phenomena related to matter, all materials and substances in the universe. This includes everything from ores and biological organisms to the composition of stars and intergalactic dust. Anything with mass falls within the domain of matter. From this collection, we ask, can we identify a set of fundamental component parts? Just as we ask, can a set of principles be found within the set of all biological phenomena? The answer is yes. The fundamental component parts of all matter are the 118 elements listed in the periodic table. All matter can be broken down into different arrangements of these elements, just as all biological phenomena can be deconstructed into aspects of the four principles in the viable set. We are not reducing for the sake of reducing. We are reducing to build and create. With the periodic table of elements, we can create new substances and compounds by combining elements in novel ways, industrially producing materials that either do not occur naturally or previously existed only in small quantities, much like how principles in the viable set can be applied and utilized across new forms and mediums. With the 118 elements, we can ask the same question again. Are there fundamental component parts into which all 118 elements can be decomposed? Again, the answer is yes. The elements can be further broken down into components of three subatomic particles, electrons, protons, and neutrons, in the same way that the viable set of principles can further be broken down into patterns. Again, we are not reducing for the sake of reducing. We reduce to build and create. With an understanding of subatomic particles, we can create new, unstable elements that do not occur naturally through experimentation. Elements can now be transformed into other elements through nuclear fusion and fission, releasing radiation in the process. This understanding has led to the development of nuclear weapons and nuclear energy. Similarly, with an understanding of patterns, we can apply patterns to any biological phenomenon we wish to study, and even use them to create general theories for any observable phenomenon in the universe. With the advent of advanced technology and better sensors, newly discovered phenomena of matter must be collected and accounted for. The existence of elementary particles, findings from bubble chamber experiments, spectroscopy, particle accelerators, and even astronomical objects like neutron stars, all must be accounted for in a complete theory of matter. So far, the theory that has successfully accounted for these newly discovered phenomena and experimental findings is the Standard Model of Particle Physics, which categorizes all matter in the universe into 17 distinct elementary particles, or fundamental component parts. Unfortunately, there is no equivalent for Patternism. For Patternism, there is no smaller component or more fundamental principle beyond patterns. Patternism ends with patterns. We have broken down all matter in the universe into a set of elementary particles. We have broken down all biological phenomena into a set of fundamental principles. These two acts are the same. How is this possible? What is it about the universe that allows us to make such reductions? What is it about the universe that allows us to use these reductions to build and create? Patternism is the belief that there is an inherent patternist structure to the universe, an inherent structure that allows the breaking of an entity into a set of fundamental component parts, an inherent structure that allows the breaking of all related phenomena into a single set of interacting principles, an inherent property that allows the separation and grouping of entities in a consistent manner. Patternism is the belief that patterns, and the paradox of the pattern, form a fundamental aspect of reality in the same manner that time and space are fundamental. The Patternist approach to developing a complete theory of intelligence is through the use of patterns. Without patterns, there can be no theory creation. Without patterns, there is no collecting of phenomena, no organization of phenomena, no extraction of regularities to serve as principles for a theory. Without patterns, simulations are impossible. Language and symbols would hold no meaning, and there would be no way to generate representative entities to search for equivalence in reality, no predictions to test for validity. Without patterns, there is no crafting of a theory. If what is presented here proves insufficient in the accounting of intelligence, consciousness, evolution, and the entirety of all biological phenomena, then one is free to pursue an alternative theory, to find a different set of principles. The means to do so have been fully described. Seek patterns. All else will follow.